we can recognize and generate equivalent fractions. Let's practice this by combining and partitioning fractional pieces on a model and number line. What fraction is represented in this model? This model represents sixths because there are 6 equal pieces to make a whole. 4 of those 6 are shaded, so 4/6 is the fraction represented here. The problem asks us to cut each sixth into 3 equal parts. Now what fraction is represented? We need to cut each of these sixths into 3 equal pieces. There are no longer sixths because the size and the total number of pieces to make the whole has changed. It takes 3, 6, 9, 12, 15, 18. 18 equal pieces to make the whole. So each piece is now 1/18. We see that now it's not just 4 pieces that have been shaded. 12 of the 18ths have been shaded. 12/18 is the fraction represented after we cut each piece into 3 equal parts. The same amount or the same area has been shaded blue in both of these models. So 4/6 and 12/18 are equivalent fractions. Let's take a look at another example. What fraction does this point on the number line represent? There are 10 equal segments to make a whole on the number line. So this number line represents tenths. The point is located 4 1/10 spaces from 0, so the point represents 4/10. The problem asks us to combine every 2/10 together. We are able to combine 2/10 because 10 is divisible by 2. So combining 2 of them will still give us equal pieces to make the whole. These 2/10 can be combined. We can continue to do the same to every 2/10 on the number line. So now what fraction does the point on the number line represent? The number line does not have 10 segments to represent one whole. It now has 1, 2, 3, 4, 5. 5 equal segments, which represents fifths. The point is no longer located 4 spaces from 0, but it is now located 2 of the 1/5 distances from 0. So the point represents 2/5. 2/5 and 4/10 are equivalent fractions. In this example, the problem asks us to find the number of 12ths that are equivalent to 2/3. We could use a number line to figure out what number we could place in the box to make this equation true. The number line needs to show thirds, which means there are 3 equal segments to make one whole. We know that this is 1/3 and 2/3. We need to see how many 12ths will represent the same distance from 0 to 2/3. 12ths tells us that we need 12 equal parts to make the whole. 12 is more than 3, so I know I need to partition each segment an equal number of times so that I still have equal parts. I know that if I partition each third into 4 equal parts, it'll give me 4, 8, 12 equal parts to make the whole, or 12ths. Fractions are equivalent when they represent the same distance on the number line. 2 segments will not represent the same distance. We can count how many 12ths represent the same distance as 2/3. 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12. 8/12 is equivalent to 2/3. Let's take a look at one more example. In this equation, we could use a model to figure out how many thirds would be equivalent to 4/12. Let's start with a model that shows 4/12. This model has 12 equal parts to make a whole, and 4 of those 1/12 pieces are shaded. To make this equation true, we need to make a model that has 3 parts to make the whole. 3 is smaller than 12, so we need to combine some pieces until we only have 3 equal pieces to make the whole. There are 3 rows on the model. We can combine the 4 pieces in each row to make 1 piece. Now we have thirds. 4 of the thirds no longer represent the same area. We need to see how many thirds will represent the same area as the 12ths. 1, or the 1/3 piece, represents the same amount of space or area. So 1/3 is equivalent to 4/12. When making equivalent fractions, we can use more or less pieces depending on whether we combine or partition all the pieces. The fractions are equivalent as long as the area on a model or the distance on a number line is the same.